carboxylic acids, carboxylic acid functional group COOH functional group, or you can write C double bond OH group, or you can also write C double bond O. Again, there is bond between oxygen and hydrogen. The acidic nature of carboxylic acid is due to presence of acidic hydrogen. The hydrogen which is bonded to oxygen. Due to this hydrogen, carboxylic acid acquires acidic nature. General formula RCOOH. R is equal to H also. General molecular formula CnH2nO2. N equal to 1 also. CnH2nO2. If N equal to 1, CH2O2, which is nothing but HCOOH. Now, common names. Common names are obtained depending on source or occurrence. For example, formic acid present in red ants, ANT, red ants. So that is why HCOOH is called formic acid. IUPAC name alkanoic acid. Alkanoic acid. Oic acid is secondary suffix for carboxylic acid functional group. An is primary suffix. Alk is root word or word root. For example, HCOOH, only one carbon atom is there. So therefore root word is meth. An, oic acid, methanoic acid. Lower carboxylic acids. Lower carboxylic acids. Higher carboxylic acids. Higher carboxylic acids, generally these are called fatty acids. These are called fatty acids. Lower carboxylic acids means up to N is equal to or less than or equal to 12. N greater than or equal to 12. You can remove equal to. N greater than 12 is treated as fatty acids. Whatever it may be, whether it is aliphatic carboxylic acids or alicyclic carboxylic acids or aromatic carboxylic acids. If N is greater than 12, generally they are called fatty acids. Now see some carboxylic acids. HCOOH, formic acid, IUPAC name methanoic acid. N equal to 2, C2H4O2 can be written as CH3COOH. It is called acetic acid. 2 carbons, single bond, carboxylic acid, ethanoic acid. This is known as propionic acid. IUPAC name propanoic acid. Propanoic acid. CH3, CH2, CH2, COOH. Both common names and IUPAC names are important. Butyric acid, butyric acid, butanoic acid, CH3, CH2, 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 COOH. This is called valeric acid. So this is pentanoic acid. IUPAC names are not important for carboxylic acids. Generally, we use common names only. Common names are important. Valeric acid. CH3, CH2, 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 COOH. This is called caproic acid. Caproic acid. Hexanoic acid. CH3, CH2 taken 6 times COOH. I am giving only important acids. It is called caprylic acid. Caprylic acid. It is called 6 to 8. So octanoic acid. Octanoic acid. Next. CH3, CH2, 8 COOH. Its IUPAC name DEC, 10 carbon atoms are there. Decanoic acid. Decanoic acid. But common name, important common name is capric acid. Capric acid. Next, CH3, CH2 taken 12 times COOH. This is called myristic acid. CH3, CH2, 10 COOH. This is called 12 carbon atoms are there, therefore it is called dodecanoic acid. Dodecanoic acid. But important common name is lauric acid. Next, CH3, CH2 taken 14 times COOH. 16 carbon atoms are there. Therefore, hexadecanoic acid. It is also called hexadecanoic acid, but important common name is palmitic acid. Palmitic acid. These are used in the preparation of soaps, detergents, shampoo, like that. Next, CH3, CH2, 16 times COOH. This is called stearic acid. So, lauric acid, myristic acid, palmitic acid, stearic acid, these are used in the preparation of soaps, detergents, and shampoos. These are fatty acids. So, sodium salts of fatty acids are used in preparation of detergents, soaps, and shampoos. Now, in case of alicyclic, carboxylic acids, suppose if you name this as cyclopropanoic acid or cyclobutanoic acid, which is correct. If 4 carbon atoms are there in compound, therefore it is butanoic acid. But cyclobutanoic acid, so that means it is not a derivative of cyclobutane. So therefore, both the names are wrong. So therefore, in case of alicyclic carboxylic acids, we use cycloalkane name, and due to presence of COOH group, we call it as carboxylic acid. See, for example, cyclopropane carboxylic acid. Cyclopropane carboxylic acid. Now, this is known as cyclopropentane carboxylic acid. Cyclohexane carboxylic acid. Cyclohexane carboxylic acid. In case of aromatic acids, benzene, if one of the hydrogen atom is replaced by COOH group, then it is called benzoic acid. Benzoic acid. COOH. This is orthohydroxy benzoic acid. But what is the important common name of this compound? It is called salicylic acid. Salicylic acid. Suppose If one more COOH group is present at ortho position, then it is called phthalic acid. Phthalic acid. If COOH groups are present at 1 and 3 positions, or you can say meta position, one more COOH group is there, then it is called isophthalic acid. Isophthalic acid. If COOH groups are present in 1 and 4 positions, or in benzoic acid, one of the hydrogenate para position are replaced by COOH group, then it is called terphthalic acid. Terphthalic acid. If ortho position hydrogen atom is replaced by NH2 group, then it is called anthronylic acid. Anthronylic acid. These are some important carboxylic acids. Now, dicarboxylic acids. First compound in dicarboxylic acid series, COOH. Its name is oxalic acid. Eth 2 carbons, ane single bond, dioic acid because two COOH groups are there. Ethane dioic acid. CH2COOH, next carboxylic acid. This is called malonic acid. Now it is called propane 1, 3 dioic acid. Dioic acid. See, 1, 2, 3, 3 carbon atoms, prop, single bond, in 1 and 3 positions, dioic acid, 2 COOH groups are present. Like that, we write IUPAC names. But for these compounds, IUPAC names are not that much important. Common names are very, very important. CH2, CH2, COOH, COOH, succinic acid, butane 1, 4 dioic acid, 1, 4 dioic acid. Now, CH2, 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 COOH, COOH. It is called glutaric acid. This is 1, 2, 3, 4, 5 pentane 1, 5 dioic acid. I am increasing one more carbon atom here. COOH, COOH. This is called adipic acid. Adipic acid. So it is hexane 1, 6 dioic acid. So again adipic acid will come in polymers, but polymers topic is not there for board exam. In board examination, chemistry in everyday life, metallurgy, polymers, these topics are completely deleted for you. But these topics, metallurgy, chemistry in everyday life, polymers, these three topics are not deleted in the NEET examination. Remember that. So if I finish D block elements, only topic left for your board exam, D block elements. If I finish D block elements, then your total uh, board syllabus is finished. So if I finish metallurgy, polymers, chemistry in everyday life, then total syllabus for NEET entrance examination is finished. Remember. So only for board syllabus, only one topic left, that is transition elements, or you can say D and F block elements. Adipic acid, right? So these are some important acids. First, oxalic acid, malonic acid, succinic acid, glutaric acid, adipic acid. So remember like this: oh my, such good apples. Oxalic acid, M malonic acid, S succinic acid, G glutaric acid, A adipic acid. So it contains 2 carbons, 3 carbons, 4 carbons, 5 carbons, 6 carbons. HC double bond C, H, COOH, COOH. So here 2 stereo centers are there. This is a stereo center, means the carbon which is in double bonding, or here carbon atoms are involved in frozen rotation, and next the carbon atoms are bonded to two different groups, therefore exhibits geometrical isomerism. So this is a cis isomer. Cis isomer is called malic acid, and HC double bond C, H, COOH, COOH. This is called fumaric acid. This is trans isomer. These two are very important compounds. CH, COOH, CH, 2COOH. So this is succinic acid actually, if hydrogen is there, but in succinic acid, if one hydrogen at carbon is replaced by OH group, then it is called malic acid. MALIC, remember, MALIC here, malic acid. CH2COOH, CHOH, COOH. So this is chiral carbon. No, this is not chiral carbon, because this is again CH2COOH. So there is no chiral carbon in this. Okay. 1, 2, 3. 1, 2, 3. This is 4th carbon, 5th carbon. So that means here hydrogen is not there. COH, COOH, right? So 1, 2, third and fourth are same. So that is why it is not a stereo center. It is not a chiral carbon. So remember that this is citric acid, which is present in lemon. Two important compounds are there. They are, see here, C6H5, CH double bond CH, COOH, which is called cinnamic acid. Cinnamic acid. Here in the cinnamic acid, if phenyl group is replaced by methyl group CH3CH double bond CH COOH, it is called crotonic acid. Crotonic acid. Crotonic acid. Now CH2 double bond CH COOH, vinyl group, and COOH group is bonded to it. This is also important. Again, it will come in polymers topic. Acrylic acid. Acrylic acid. Now CH2 COOH NH2. So this we discussed in biomolecules. You know this. Alpha amino acetic acid or 2 amino ethanoic acid, or important name is glycine. It is called glycine. CH3 CHOH COOH. This is called alpha hydroxy propanoic acid. Alpha hydroxy propionic acid. The important common name for this is lactic acid. This is called lactic acid. C6H5CH2. This is benzyl group. For this benzyl group, if COOH group is attached, this it is called phenyl acetic acid, or it is phenyl ethanoic acid is also correct. It is a correct IUPAC name. Phenyl ethanoic acid. ETHANOIC. Ethanoic acid. Clear? Acid derivatives esters. So remember, the general formula of or functional group of ester is COO functional group. Can also be written as, remember, it is a divalent functional group. Two free valencies are there. Two free valencies are there. It's divalent functional group. Divalent functional group. Can also be written as C double bond O. O. This is a divalent functional group. This is the structure of ester functional group. The general molecular formula of esters is CnH2n2. So therefore, compounds with the same molecular formula, compounds with the same molecular formula, acids and esters are functional isomers. Functional isomers. Now, general structural formula. General structural formula. General structural formula. See here, RCOOR. It is a symmetrical ester. RCOOR dash, unsymmetrical ester. Or this is called a simple ester. This is called mixed ester. Mixed ester. Now, here R is not equal to H. Here R dash is not equal to H. But here R is equal to H also. Suppose COO group. Here hydrogen is attached. This hydrogen is bonded to oxygen, is it not? So therefore, this hydrogen possesses acidic nature. Acidic nature. So therefore, it is a carboxylic acid. It is a carboxylic acid. If hydrogen is bonded to carbon, hydrogen is bonded to carbon, then it is not acidic hydrogen. It is not acidic nature. It is not acidic hydrogen. So therefore, it is not an acid. Not an acid. Clear? So R C double bond O R dash. R dash is not equal to H, but R may or may not be hydrogen. May be hydrogen, may not be hydrogen. Now, these are considered as derivatives of carboxylic acids. Carboxylic acids. Clear? Now, see carefully. R C double bond O R dash. Now, this is treated as alkyl group, and remaining part of the acid is called alkanoate. Alkanoate. See, for example, RC double bond OH. This is acid. Oic acid, right? Oic acid. Now, RC double bond O. This is called O8. Carboxylate. O8. So, for example, RC double bond O, CH3 is there. Then it is called methyl dash O8. If RC double bond O, C2H5, ethyl group is substituted. Therefore, ethyl O8. So, which means that the IUPAC name of the ester is alkyl gives base alkanoate. So RC double bond O R dash. This is alkyl group and alkanoate. Remaining part of the ester is called alkanoate. Remaining part of the ester is called alkanoate. So whatever be the alkyl group, whatever may be the alkyl group bonded to oxygen is treated as substituent. Treated as substituent. Now see for example HCOOCH3. So this is the methyl group bonded to oxygen. Therefore this is called methyl methanoate. Only one carbon is there. So meth, ane, oate, methyl methanoate or HCOOH. This is formic acid. In formic acid, hydrogen at oxygen is replaced by methyl group. So this is called formate group. Therefore, its name is methyl formate. Suppose if you have ethyl group, then it is called ethyl methanoate, IUPAC name. Now, HCOO group formate, ethyl group is there. So, therefore, it is called ethyl formate. Now, CH3COOH. Remember, this hydrogen is bonded to oxygen. So, therefore, it is acid, acetic acid. So, see, HC double bond OCH3. CH3C double bond OH. Hydrogen is bonded to oxygen, acid. Methyl group is bonded to oxygen, therefore ester. Both are having same molecular formula. So therefore these are functional isomers. Functional isomers. Clear? CH3 C double bond O CH3. CH3COO group, acetate group. To that methyl group is added. Therefore, methyl acetate. Methyl acetate. See here, methyl group and this group is ethanoate, methyl ethanoate. Similarly, CH3, CH2, COO, CH3. This methyl group is bonded to oxygen. So therefore it is substituent, methyl. Remaining part of the ester, 3 carbon atoms are there. So prop, ane, O8, methyl propanoate. So like this, we name esters according to IUPAC system and common names also. In, for example, CH3, CH3, COOH. This is called isobutyric acid. Isobutyric acid. But its IUPAC name is 1, 2, 3. 2-methyl. propanoic acid.